Hi, I'm Bill Alderson. Hey, welcome to a little session on IT complexity acceleration. Hey, thanks for stopping by today. I want to talk to you about these issues affecting complexity and its acceleration. First of all, what do we have? We have technology. Every area of technology is getting more and more complex. Now, sometimes it makes it better. Less problems, and that sort of thing. But there's a lot of new technology out there that's actually making things much more complex. Multi-tier applications, SOA interfaces. That's interfaces to other people's data that you're bringing into your application. You've got WAN optimizers. You've placed in between your client and your server additional devices that are taking the data, compressing it, encrypting it, optimizing it for certain applications. Some applications it's on, some applications it's off. Sometimes it works good, sometimes it doesn't work good. But man, let me tell you, when there's a problem, there's a problem. It requires detailed analysis. Why do you think that Riverbed bought all the developers of Wireshark? Because they had to. The complexity of the technology is vastly accelerated over what a standard client-server architecture. You could see every router, every switch, every device between the two. Now you put in these very quiet WAN optimizers. You also have other things like load balancers. Those load balancers go in between the servers and the clients. So when you do a TCP connection, you connect up to the load balancer. The load balancer then sends another request on a separate TCP port, another OSI model, and goes to the server. So you're really not interacting from client to server. You're interacting from client to WAN optimizer, to WAN optimizer, to load balancer, from the load balancer to the server. Vastly more complex. In addition, we have on the network interface cards in all of our devices, we now have TCP offload engines in order to be able to do more with the processor on the board and take away from the processor in your CPU processor in your hosts and in your clients. So the TCP offload engines are taking that and putting them in the offload. That's yet another set of complexity, another set of dynamics to where you're not truly communicating from the client to the server. Okay? And we're in a day and age where we're buying lots of monitoring tools and systems and equipment. We have a plethora of men in the middle. I call them our man in the middle. Those load balancers, those TCP offload engines. Then you have firewalls. Sometimes the firewalls are actually taking sessions from the client to the server and in between changing TCP options. Now, you think, okay, well, that's good. Well, all of these things are good, but if you don't have analysts who can really look at this data when something goes wrong, you can't really troubleshoot until you get the next round of what? Of forklift upgrading, okay? And that's what the vendors are counting on typically. We're doing very little to optimize what we have today. Everything seems to be having to be attached to a new technology before we'll do anything. So there's many free options to optimize, to tweak, to improve the relationship between the client and the server. Those load balancers, those WAN optimizers, all of these different things we can optimize if we take the time to do it, and we can get huge ROI, huge bang for the buck by using brain cells to analyze things instead of just budget to buy new stuff. Okay, your IT silos, your departments are growing, your budgets are greater, there's more complexity, there's more dependency. And because of those greater budgets, we have more different silos. So we're diversifying our budgets even more. And in between those silos are walls that go up. When there's a problem from client to server, and you've got the desktop, you've got the firewalls, you've got the network, you've got the load balancers, you've got the WAN optimizers, you've got the servers, you've got the applications. Now, when there's a problem, who do you go to? Well, there's very few generalists. And in fact, that's another topic here. We've got personnel specialization. all of our folks are becoming like doctors. They have more and more vertical specialization. So when you have a problem that's from client to server and somewhere in between, you have to assemble a huge team of people to basically address all the various issues associated with that technology. And so there's very few people who really understand from client to server and all points in between. You have very few generalists today, and a lot of knowledge is hidden from the various people who would like to know more, who would like to be more generalists, because the silos are hiding information from one another so that no one can accuse them of a problem. So it's a growing divided support group problem because of personnel specialization. Okay, so, and last but definitely not least, and an emerging growth trend, is the move to the cloud. What do we have? We've got remote data centers. We've got data centers that are being consolidated. We have fewer of them, and they're further away from us. They're lights out. There's less knowledge. There's less intimacy with the technology. There's less interaction with the technology. It's a separated support group from who usually takes care of those things. It's a lights out operation. Everything has to be done virtually. And if it has to be done virtually, that means documentation must be at the very highest ability and highly collaborative. And of course, that's a problem as well. Okay? So, here's some things that will help you with this IT complexity acceleration. Number one, take a look at architecture ownership. I have some pieces I talk about in my best practices about architecture ownership. Number one in architecture ownership is know yourself. That means that you document your systems, you document your network, you document where those load balancers and WAN optimizers are, you document both sides of them so people can see how their packets are being treated, you document your NetQoS, your quality of service metrics. Everything is documented so the technologist who's trying to look at an end-to-end communication session knows exactly what's affecting their packets and their systems. Okay, so after you have documented your system and it's very good and it's highly collaborative, you need to train everybody and certify people on your architecture. Don't let anybody into your site. Don't let anybody have the keys to your servers and your routers and your switches and that sort of thing until they truly understand your architecture. And that is only done by showing them the diagram, showing them your architecture, showing them the packet flow, showing them the application flow, so that they are fully understanding of the client to server before they get in there and start tweaking things and breaking things. That change that you're having problems with, I know you don't like change anymore because it imputes problems into your environment. I totally agree. But if you have people who understand all the pieces of the puzzle across all the business silos and understand end-to-end transactions, you're going to be much better off in that capability. Now, so architecture ownership, take a look at my best practice on that. Second, decision support metrics. Decision support metrics allow you to find out if I upgrade that server, if I upgrade that database, if I upgrade that network connection, if I upgrade that SAN, what is it going to do exactly for the response time of my mission critical application? Is it going to go from 25 seconds down to 18 seconds? Is that what it's going to do? Well, then why are you spending millions of dollars on it if you don't have a quantification? Maybe you don't have any application performance management, APM, in your environment. Maybe you've bought all of those tools, but they're actually not working. Maybe your help desk can't even use them. So, you can buy tools, you can buy systems, but if your technologists are not using them, so they may be bought by one of your IT silos but not shared in the other silos so that they can gain the benefit of an understanding. So your tools may also be siloed as well. Your tools should have an end-to-end, cross-technology, cross-silo view to them. Okay, so then the other thing is your silos. Their walls are growing in them. Business technology integration, the building of virtual groups so that you basically take a look at network documentation, metrics across the entire enterprise, not within a silo. So right now, if you go out to your silos, they all have documentation, but nobody has typically an end-to-end view of how the end user is affected. And all these silos are being, lauded, and they're doing wonderful work and that sort of thing, but if you talk to the end user community and the business unit folks who are impacted by slowness and intermittent problems and that sort of thing, you get a different picture, right? Okay, I know it because I hear it, I see it, I feel it, I talk to people, I get called in to solve these problems. Okay, so you need virtual teams to deal with documentation, metrics, and optimization of your environment. Okay, now, you need a master plan. So I've got some stuff on master plan. And last, application optimization during development and operations. You need to take and look at your systems from end to end. Find out what your transactions are doing. Tweak your metrics so that they are pinpointed and getting signatures of your application performance. Okay, well that's enough for today about IT complexity acceleration. Join our communities. Let us know what you think about these videos and the information. Really, these pieces of data are valuable. If you take a look at them and you think about them and you integrate them into your mind and your thinking, you'll be a very successful IT executive and Chief Information Officer. I appreciate you stopping by. I'm Bill Alderson, and my very best to you today.